Hello, welcome to a presentation on disaster planning, planning for the worst scenario. So, level of recovery, it's the determinant factor in disaster planning is to what level of recovery of data and equipment is acceptable. So that's a big question. Do you want to be recovered to 1 day, 1 hour worth of equipment? You want to be able to recover in 15 minutes? It's okay to be offline for a week. The plan must address both hardware and software needs, power, redundancy, and high availability. Redundant power supplies. So power considerations, redundant power supplies. Critical servers have dual redundant supplies. If one power supply fails, then it automatically falls over to the second power supply. Usually they're hot swappable power supply modules, so that if one fails, then you can pop it out, put a new one in, and you're ready to continue on. Each supply is connected to a different AC circuit. Power supply circuits are separate from normal AC circuits. So power supply circuits for computers are a separate circuit, and typically they'll use orange plugs. So the industry standard is to have an orange plug that says only computer equipment can be hooked up to it. White plugs are used for things like you can put your blender in it, motors, electrical, they're noisy. Here's an example of redundant power supplies. It looks like there's 1100 watt power supplies, hot swappable, they can plug out. Notice that they have separate AC cords on them, so that way they would go to separate AC circuits. Each server power supply is connected to a UPS. It provides clean power, no noise spikes, no voltage fluctuations, no brownouts, temporary voltage loss. Brownouts or temporary voltage loss, provides a clean sine wave signal, a constant voltage level. It could be 120 volts AC or 240 AC. What we're seeing nowadays is a lot of the power supplies are able to function perfectly fine on 110 volts, 120 volts, and all the way up to 240. Here's an example of some UPSs, uninterruptible power supplies. The big one in the upper left corner, that would be a supply that we would see in a data center. So say it has two big maybe four big UPSs like this. They'll provide about 100,000 kilowatts each, so they have about 400,000 kilowatts of backup power. Smaller ones will be rack mount ones, like in the upper right corner. That one's the rack mount one. It'll have a whole bunch of batteries, weighs a lot of weight. I tried pulling one out and it slipped, fell on my finger, and cut it just from the weight, and that because it's all basically filled with lead acid batteries, and that one would power probably 6 or 8 servers off of that one unit. Below it is we have some smaller UPSs, and typically what these will do is power 1 or 2 servers each. The bigger they are, the more batteries and the more time they have. UPS's service is rated by voltamps. How much clean power can the UPS provide? To find the wattage, multiply by 0.6 or 60%. So a 1500 volt UPS will provide 900 watts. So you add up the wattage of all devices connected to the UPS, and they cannot exceed the UPS's maximum wattage rating. You always overrate your UPS. So UPS batteries are rated by amp hour. How long can they provide backup power? For example, a 2.5 amp hour battery can provide 2.5 amps for 1 hour. Theoretically, 5 amps for 30 minutes. So the more current, the less time. 10 amps for 15 minutes. Usually you have multiple 12 volt batteries in series. I got 10 marked there. Specifications for APC UPSs is a backup runtime full load is only about 4 minutes. Half load 13 minutes, and the maximum battery recharge time is 16 hours. UPSs will keep servers up and running for 10 to 15 minutes at the maximum. It's based on the AC load and battery life, the amp hour. UPSs can communicate using USB, Ethernet, or serial ports to the server to tell it that power has been lost. A server then can be programmed for an orderly shutdown so data is not lost. Data can be lost because it resides in RAM, so you don't want to have a server running and all of a sudden lose the power and you're going to get misconfigurations. Data will not be stored properly on the hard drive, etc. Something else is normally, it's like a warning. The power fails, UPS keeps running, and then after 5 minutes or something, it says, hey, this is a big power failure. We're going to talk to the server. So here's an example of a UPS that's communicating to the master server here. And what happens is that when the power fails, UPS communicates with the master. The master is running a program and says, okay, we got a power failure. It's going to start a preset countdown that says, okay, the UPS can only provide power for so many minutes. So after 2 or 3 or 5 minutes, I'm going to start shutting down. And then what it also does is it communicates to slave servers like these ones. It'll communicate and say, we got a problem here. You guys got to shut down, and everybody will orderly shut down. UPS server software, here's an example of APC PowerShoot, right? It says, okay, what port are you going to communicate to the UPS on? And are you going to use USB port? And keep my computer on as long as possible or preserve battery power. And then you'll notice you have a sliding scale here that says 2 minutes, 4 minutes, 6 minutes, 8 or 10. And basically shutting down after this looks like 5 minutes after it has been notified. This one says 10 minutes after. For long-term usage, greater than 15 minutes, what we'd use is a backup generator. It's spec'd for hours of operation. It's diesel or gas powered and can run for days if needed. You just keep adding more fuel to it. Takes several minutes to turn on and run, so you definitely need a UPS for this time frame, and it's housed outside of the facility. SAIT has a UPS. It's rated for 1 million watts of amp hour power, and it runs. And basically, they have a backup generator that's rated for 1 million watts, and what they have is their UPSs at the data center that will keep the equipment running for a specific number of time, specific amount of time, and that. So here's a couple. This is a really big one. SAIT's got a big one like this, and then you have smaller ones like this. What you also want to have is separate feeds from 2 different AC electrical grids, right? If one feed fails, then it falls over to the second. So basically, in a building, you'll have a main breaker panel like this that's coming in. You have one feed from, say, NMAX, another one from direct energy or something like that. So 2 separate grids, and then if one fails, it clips over to the other one. Server hardware, RAID, redundant array of inexpensive disks. We've talked about this before. They're hot swappable hard drives, mirrored images. RAID 6 is the one we would want to go for. Data is okay even with 2 failed drives. We're able to recover if 2 drives fail. The reason we do that is typically we'll build a server and we'll buy all the drives at the same time, plug them in. And historically what we'll find is that when one drive fails, another will fail when they're built about the same time. Something that we can use for monitoring is called SMART, Self-Monitoring Analysis and Reporting Technology. Detects and reports on indicators of drive reliability and predicts early signs of hardware failure. Here's an example of a RAID array. What we have is a bunch of hot swappable hard drives in this server, and then they're combined into a RAID volume. Another thing that we can do is we can have a high availability clusters. What they are is mirrored servers that monitor each other using a heartbeat. If the heartbeat is lost, the secondary server takes over. And this can consist of hundreds of servers. So in this example here for failover, we have a high availability cluster. We have a high availability IP 10.0.0.100, and it would be in a switch or a router or a specific server dedicated to this task. And what we see on the left side is 10.0.0.101, which is our active server. This one's the one that is active, is running. And in between the active server and the passive server on the right-hand side at address 10.0.0.102, I see the IP address is wrong there. There's a heartbeat, and the heartbeat runs back and forth. So it tells the active server the passive server is alive, and tells the passive server the active server is alive. What happens is that all the actions happening on the active server, and what it's doing is replicating all the data that's being changed onto the passive server across a very fast network. If for some reason the active server dies, what will happen is that the switch at the high available IP address up here will automatically switch over to this guy. The heartbeat will die. This guy will be up and running, and we will have failover. SANs and NASs, storage area networks and network attached storages. Data can be stored on these devices. One place for all data to reside. Devices are optimized for reliability, and we have one source for data backup. Data backups, the frequency of data backup is determined by the acceptable level of recovery. It could be monthly, weekly, daily, or hourly. Usually requires server apps to stop, scheduled for specific times a day. You can have full backups or incremental backups. The latest technology is to constantly back up while server runs due to the large size of storage. We're having terabytes of data. And what we find is that even if we stop a server, we cannot back up overnight terabytes of data. So we back up while the server runs, and that's called deduplication. And that's the latest technology for that. A decision has to be made on what to back up. Complete drive images, just the data, determined by how quickly you need to return to a level of service. What to back up. Backup storage location. Do you want it on site? If it's on site, it should be a secure location, fireproof and waterproof. Off site, it could be local, which could be local to the city you're in, or the state or province, or it could be in the cloud. You can back up to the cloud. Some disaster failures. A really good example is New Orleans during Hurricane Katrina. The typical thought for backup location was to put them in bank vaults, right? So they're stored in bank vaults daily or weekly. They'd bring down their copies and dump it in the bank. But what happened is the banks were underwater for several months. So we ended up with a problem where, yeah, we have them backed up. They're in the bank, but we can't get to the bank because it's underwater. Another one was backup batteries for cell towers. So what happened in the Hurricane Katrina is that all the communications towers worked, all the cell phones. We had communications. We had no power to them, and the sort of the train of thought back then was that we'd store the batteries in the basements. First place to flood were the batteries in the basements, and we had no power. So now what happens is they're storing batteries on second floors and third floors, so that even if the basement floods, we still have equipment, our power to run our cell sites. New York City, 9/11, Verizon lost 10 cellular towers along with 300,000 voice lines and 3.6 million data circuits, affecting 14,000 businesses and 200,000 residential customers. The building was located next to the World Trade Center, which collapsed, and when it collapsed, it knocked out part of the 36-story Barclay Vese telephone building. It took months to completely rebuild. I remember they were saying there was like thousands of miles of cable that had to be rerun. So basically what they did is they realized that they had too much equipment all in one local place. Verizon had another one is during the Hurricane Sandy flooding. This is another one where they put equipment in the basement of a building, and what they had is 5 levels of basement flooded. Right, and that was their New York City main communication hub. So it flooded, and they had 100,000 users without communications. A Calgary Shaw fire. So Calgary had a minor fire in downtown Calgary, and the sprinklers take out the backup systems. So what happens is the problem began when a transformer exploded at Shaw's downtown Calgary headquarters on a Wednesday afternoon. The fire set off the building's sprinkler systems, which took out the backup systems which were housed on site. Because of the fire, IT people were locked out from the building and couldn't repair the backup system. Right? So when you create a recovery plan or a disaster plan, what you have to do is test every aspect of the data plan. Most companies never find out if the data plan works until it is too late. I had an instance where I had to do recovery on a server, and what happened was the software that we were backing up the server with was old, and the latest recovery software was new, and it wasn't compatible. So we had to search the company to find out an older version of software that would work with the the backups that we set. So that's all for today for recovery testing and disaster planning. If you like this, hit the like button and subscribe. Put some comments down below. Thank you very much for listening.